Assalamualaikum warahmatullahi wabarakatuh. We are from Group 4, consists of Meli Setiawati, Alfeara Pascaviwi, and me, Feby Fitri Permadani, wants to present our major assignments about the design and analysis of optical fiber networks from point to point, which is from STO Pasar Baru to STO Pakulonan. First, we are going to present about the theory and discussions. Optical fiber is a type of cable made of fine glass or plastic fibers that can transmit light signals from one place to another place. There are single-mode and multi-mode as optical fiber types based on the number of propagating modes. Meanwhile, there are step index and graded index as the optical fiber types based on the refractive index of the core. In this design, we choose single mode. Why? Because it can carry data with larger bandwidth, faster, and 50 times farther than multi-mode, and it has a smaller core so that it's minimizing the disruptions in it due to distortion and overlap of light pulses. So compared to multi-mode, this is what causes single mode to be over-reliable, stable, fast, and far-reaching. In this design, we are using G655 single-mode optical fiber, which is the general specifications for step index. So, we choose step index for the type based on the refractive index of the core.
So for the light source, there are two types. The first one is LED or light emitting diode, and the second one is laser or light amplification by stimulated emissions of radiations. So for the LED, it can modulate the signal bandwidth up to 300 MHz, and it is less suitable for long distance transmissions. Meanwhile, for the laser, it is able to modulate signal bandwidth up to 2.5 GHz and more suitable for long distance transmission. And for photodetector, there are two types. The first one is PIN or positive intrinsic negative. It has an intrinsic semiconductor between P and N parts which serve to absorb more photons. And for the APD or avalanche photodiode, it has better sensitivity than PIN diodes. And then APD can be used in long distance communication with LED as the optical source.
Now we will discuss the system model. The route we choose is STO Telkom Pasar Baru in the city of Tangerang to STO Telkom Pakulonan in South Tangerang. The following is an illustration of fiber optic communication system that is 13.6 km away. STM16 was chosen because it is based on user needs in the region developing that is 2.5 Gbps. The speed is SDH-ITU-T fiber optic transmission standard. In this of the system simulation, the performance of the system can be seen from several parameters related to the data transmission process, such as the parameters on the transmitter, fiber optic cable, receiver, and canal. We input the numbers based on the fiber optic network planning parameters, and because our distance is 13.6 km, the photodetector uses this as PIN because it is more efficient for close communication and has good sensitivity for LED. After we assemble and run it, we can see and check the bare analyzer. From starting point origin STO Telkom Pasar Baru, the distance starts from 0, and why the type of cable we use is dark because the cable are all types of cable. Houses construction is specifically designed to be installed below ground level, and Core 48 is the Telkom standard, and G655 is for fibers that have a very small dispersion. And the second connection, we use the aerial type cable because it crosses the bridge as far as 100 meters. Then we use the direct barrel cable types because it crosses highways and toll roads. Starting from third connection point to destination STO, the cable installation is done by handheld.
Next is the calculations and analysis. First is the link power budget. It is one of the methods where the total attenuation is allowed along the optical link from the central to the end users. A good link is obtained if the power received at the receiver is greater than the power sensitivity of the receiver device. Here, we have to prove that our link is good or not. So, we can see that this is the manual calculations to calculate LPB. For the total attenuations, we got 13.94 dB. For the power received is minus 10.94 dBm. And next, we've proven that the LPB is fulfilled. Why? because the power received, which is the minus 10.94 dBm, is greater than the sensitivity, which is the minus 28 dBm that we got from the planning parameters. So we can say that our link is good. Next is the link power budget curve toward the distance. From the curve concludes that the farther the data transmission's distance, then the acceptance level of the distance decreases. It caused by attenuations at the 0.5 dB over connector, attenuation at the 0.5 dB over splice, and unexpected attenuations when sending data due to the long range.
So here we're calculating the rise time budget. The formula is as follows. And then first we're going to calculate the T-mat. With the parameter that we got, we have T-mat is equals to 5.02 times 10 to the power of minus 8 seconds. And then since we are using single mode, the T-mat that is actually calculated on the thesis is considered 0. Next we are going to calculate the numerical aperture. So we got here 0.13, and then for the V parameters we got 2.37. And this value of V parameters prove that we are using single mode because it is less than 2.405. Next we are going to calculate the TWG. Here we got the value, it is minus 91.3 times 10 to the power of minus 12. And after that we can calculate the thesis with the previous formula, and then we got 9.9 times 10 to the power of minus 11 seconds. And from here we can calculate the bit rate, and then from the bit rate we got 10.1 gigabit per second. And it is proven that the bitrate system is more than the bitrate demand, so the system design has met the desired criteria.
Next is the key factor. Key factor is a quality factor that determines whether the quality of a link is good or not. From the curve, we obtain the key factor value is 15.0176. So it proven that the value of the network design results meet the set standard, which is greater than or equal to 6. Next, for the eye diagram. Our diagram shows that this is the result of a well-produced eye diagram pattern, because the bigger the eye open or the larger the size, like our diagram shows, the easier it will be to detect the signals and the smaller the bit error rate.
So BER or bit error rate happens when transmitting digital signals, and then the standard for BER is 10 to the power of minus 9. So here's the result of our design. And as you can see from this picture, the minimum BER that we got is 2.8 times 10 to the power of minus 51, which means that our design is already met the requirements.
The last conclusions that we got from our major assignment is that our design is successful because the performance parameters such as bit error rate, link power budget, rise time budget, key factor, and also the shape of the eye diagram pattern are fulfilled well. The values that we get are good for use, and it can be concluded that they meet the criteria and are feasible to be implemented in the field, because the system can carry 10.1 GB per second bitrate data, which exceeds the bitrate demand, or 2.5 GB per second, that will be sent by the transmitter up to the receiver. In addition, we proven that all of the calculations did in manual calculation is as the same as in the simulation result.
The result of LPB, RTB, and RZ are fulfilled. And LPB, the farther the data transmission distance between the receiver and the transmitter, the lower the level of acceptance of the distance. Whereas in RTB, the farther the data transmission distance between the receiver and the transmitter, the greater dispersion of the system. In addition, the system has met the rest time and RZ transmission where 0.0990 nanosecond or rise time of an RZ transmission less than 0.28 nanosecond, 70% of the bit period, and the 0.0990 nanosecond or rise time of RZ transmission less than 0.14 nanosecond or 35% of the bit period.
So the conclusion, after we analyzing and designing this paper, we got several conclusions. The first one is, so from the design of the optic network of STL Pasar Baru to STL Pekalongan, as far as 13.6 km. After we calculate it, we got the LPB is 13.94 dB, the RTB is 9.9 times 10 to the power of minus 11 seconds, and the Q factor is 15.280176, and the bare orbit error rate is 2.81 times 10 to the power of minus 51. And the type of cable used is loose tube because the data transmission is carried from central to central.
So that's all our presentations. We apologize if we have mistakes. The last we said, wassalamualaikum warahmatullahi wabarakatuh.